Hi everyone, here's a quick demo of the Tracksoar. We'll start with the basic assembly. The first step is to install the AA batteries into the battery compartment. Next we'll connect the serial jumpers, which connect the microcontroller to the GPS receiver. Once these jumpers are connected, we'll see the transmit LED turn on and then go dim as it transmits and then goes into standby mode. Next, we'll look at programming the Tracksoar. We'll need an FTDI bridge to connect to the Tracksoar, and we'll need to remove the serial jumpers to program the board, otherwise we'll see an error when we try to program it. With the FTDI bridge connected, we'll open up the Arduino IDE and open our sketch. The only required changes for flight can be found in the config.h file. We'll make this full screen to make it a little easier to read. The config.h file can be found using the drop-down arrow in the upper right-hand corner. The required changes will be adding a call sign, which I've already added here, setting our icon, 11 is for a weather balloon, and adding a comment. Here I did Tracksoar beta. Once those are set, we can upload the firmware to the Tracksoar. Here we can see the FTDI bridge flashing the TX and RX lights to indicate it's uploaded. Once the upload is finished, we can open up the Arduino serial console and verify that the Tracksoar is transmitting data. This is actually the Tracksoar trying to communicate with the GPS receiver and put it into flight mode. And once we connect those jumpers, we'll see that it's transmitting a valid message. So with that all set up, we'll do a quick demo here. We see the Tracksoar at the bottom of the screen, a amateur radio above that, and on top of the amateur radio is an Android phone running APRS Droid, which allows us to decode the APRS message. The Tracksoar is set to transmit once a minute, and when it does, we'll see that push-to-talk LED go bright for about a half second and then dim again as it goes back into standby mode. And we'll show you the decoded APRS message on the Android phone. Here we can see my call sign, how the message is transmitted over the APRS network, the GPS coordinates, which in this case are zeros because we're inside under a metal roof. Normally those would show a valid GPS lock. And after that we have PA, which is pressure in pascals, RH, which is relative humidity in percentage, and TI for our internal temperature. Thank you for watching, and please support our Kickstarter.